Thank you, everyone. Let's see. Okay.
Oh, just turn it on.
Is that good?
Third button. Hey, here we go.
All right, cool. Before I continue, could you please raise your hand if you ever heard about or used Azure DevOps before? Okay, then it's almost everyone. Because it's kind of a beginner and intermediate and a lot of security controls, so some of you might have seen this before. So I'm a managing security consultant at NCC Group. I'm specialized in cloud and CI/CD security. I have some certifications, awards, and so on. And last year, me and my colleague gave a presentation about CI/CD compromises. But that was more about the on-premise, like Jenkins and GitLab and so on. So I thought that this year we can move to cloud. So Azure DevOps is a SaaS solution from Microsoft that helps deploy and build softwares, and you basically know it. So this is the usual DevOps symbol. You have the Azure reports for storing the source code. You have Azure pipeline for the pipeline and the tasks. You have something called Azure boards, where you can create the work items, bugs, or sprints, and so on. You have something called the Azure artifacts. When you build your software, you basically create an artifact, or you want to use third-party libraries that will fall into these artifacts as well. And one more thing is Azure test plans. That's where you can create and manage your test plans. So just a very quick high-level overview. Once you register Azure DevOps, you will create an organization, but later you can create more organizations as well. Within an organization, you will create a project and agent pools and groups. So agent pool will contain all the agents where all the pipeline tasks will run. The groups will contain, obviously, the users that you create. So within the project, you can create one or more repositories and one or more pipelines, and you can have artifacts or feeds. But there are other related services that's not built in or comes with Azure DevOps, so you can buy these separately. The first one is DevTest Lab, where you can scale and let your developers create their own machine where you can test your application. The second one is DevBox, where you can have your virtual machine for the developer with all the IDEs and tools that needed for creating and developing the software. Also, it's very or highly recommended to integrate Azure DevOps with Azure Active Directory, because it will come, depending on your license, but it will come with conditional access policy or privileged identity management. And there is Defender for everything, so DevOps is also not an exception. So you will have something called Defender for DevOps that will contain something like repository statistic, infrastructure as a code scanner, credential scanner, and all kinds of stuff. And the last one is Key Vault. So if you don't want to use the built-in secret management in Azure DevOps, you can use Key Vault and reference the secrets from there. So before I continue and talk about the most of the security controls, I just want to break down to three things that you might see before when we are talking about DevOps security or pipeline security. So the first one is security in the pipeline. It's when you make sure that what you create or build code, it's secure. So you put in the pipeline like a credential scanner or something like that, or a SaaS tool. While security of the pipeline is about securing the pipeline itself, so you make sure that there is no publicly available repository, or not everyone can read the secrets and these kind of things. And recently I saw the last one, which is security around the pipeline. So basically everything that's connected and outside of the pipeline, that will fall under this category. So for example, if you deploy your web application into Azure Cloud, then it will fall this category. So I will have a demo video as well after I talked about all the security controls, and we will see what could happen. So the first thing is you want to authenticate and reach your Azure DevOps. So you will do this by opening the dev.azure.com/your organization name that you created, and it will be a username and a credential. So that's why it's highly recommended to integrate with Azure AD, because then you will have the conditional access policy. So you can enforce, for example, multi-factor authentication. So we want to avoid password spray attacks or any brute force attacks or unauthorized access to our organization or projects or repositories. So here you can see two screenshots. The first one is a conditional access policy. You have two options. In this picture you can see I selected apps, so it's just one app, so you basically can choose Azure DevOps itself. But if you choose all cloud apps, then Azure DevOps will be included as well. But this is just one part of the job, because in Azure DevOps, within the organization settings, you will have to enable the security policy that says enable Azure Active Directory conditional access policy validation. Otherwise it won't work. So the next thing, once we log in, we want to allow people to do things. There will be, basically at any level or any component, there will be a security tab. So for example, for project, pipelines, agents, secrets, so you can set who can read it, write it, modify it, or delete it, and so on. But also like which pipeline can access which agent. The next thing is privilege identity management. So if you have a higher role, for example, the project collection administrator group, then you can make sure that you can use with the privilege identity management. So the user has to log into Azure portal and activate the role. So it will be approved by, for example, 2 other people. There is a role in Azure Active Directory called Azure DevOps Administrator. If you give this role to someone in Azure DevOps, then you will have additional settings that you can configure. I will have a screenshot for that. So again, we want to avoid unauthorized access on different levels. So if you have a very sensitive source code or pipeline, you don't want to share the same agent with the less sensitive one. Because sometimes there can be a privilege escalation pass, or someone could inject a malicious code, or just steal a source code from a different project. Hopefully you can see. So this is the permission tab with all the built-in groups. It's fairly well separated, but you can create your own one. This is an example for the project security tab. So you might see that the build administrator group can contribute to the code, for example, but can't manage the permissions. This is an example for the security for a build administrator, but this time it's a pipeline. And because it's a build administrator, the group will be able to modify, create, destroy pipelines and builds and so on. This is the example using privilege identity management. So you create a group, you put the member in it, and you don't enable the active assignment. So you have to log into the portal and activate the role. Yes, so this is what you will see when you add that Azure DevOps administrator role to a user. So in the organization settings within Active Directory menu, you will see and configure who can create additional organization or personal access token lifecycle and so on. So once we logged in and we have some permission to do things, first we will create the project. So by default, you can't create public projects, so you can only create private that's only accessible within the organization. So once you created a project, you will create a repository. We want to avoid unknown changes or unauthorized changes. So with the unknown changes, what I'm referring is that in Azure boards, you can create work items, and you can, when you do a modification, you can link the work items to the pull request or other things. So it can be enforced that there will be no changes that we don't know about, and there is no description of it. Also, we want to avoid introducing backdoor code or stealing repository code or the code from the repository, or just have over permissive privileges, because I saw sometimes that companies have the policy that all the developers will have a read access, so they will be able to read and access all the repository. So again, we will have the usual security options, and there is something called pipeline access. So we want to make sure that only certain pipelines, or just one or two pipelines that we created, are able to access the repository itself. There is something called commit author email validation that will make sure that once you configure Git, you add the email address, and you can see which specific email address or email patterns who can commit the code. And you can also create branches. So this is the screenshot for the security tab, and you can see this time this is the contributors group, so they can contribute and add things to the code and the repository, but again they can't manage the permission on the repository itself. This is the pipeline permission. This will say which pipeline can access which, or this in this case, which pipeline can access the repository itself. So with the 3 dots in the screenshot, you will have the option for open access that will allow all the pipeline to access this repository. By the plus sign, you can choose one by one. Here you can see on the repository the commit author email validation, so you have to enable the repository policy and then define the pattern for the email address. So once you have repositories, you usually create some branches. Here we have the options for peer reviews, linked work items, and branch controls. So here in the branch policy, you will see, hopefully, that the recommended reviewers are at least 2, and whoever makes the request shouldn't be able to approve itself. So there should be additional 2 people who can approve it. And the second option is checked for linked work items. So this is once you created a work item in Azure boards, then you can link the work item. So you will already have a description and text what will be the changes and who will do the changes. So here you can see the example that there is a work item. It's in the right corner. It's task 7 that's connected or it's there, and it waits for 2 reviewers to review and approve it. So otherwise the pull request and the merge won't be made. So once you have the repositories and pipelines, the branches. You create pipelines to actually build your code. You have two options, the build and the release pipeline. That's basically the CI and CD part. For both of them, you have the option for be a classical or YAML based. The classical is where in the web UI you click through and click what are the steps, while the YAML lets you actually type the code. And by default now the classic build is disabled. So for the pipelines, there are a couple of things I collected. The first one is argument injection. So you can have something like in a pipeline step that you step into a directory and you give the directory name as an argument, but you can add additional codes and it will behave like SQL injection or command injection as well. You can do privilege escalation through pipeline or exfiltrate data, or sometimes you don't want to automatically build and you want to make sure that only it's either in business hours that the build happens or out of business hours, so you don't mess anything up. And we want to avoid introducing any malicious steps. So instead of using arguments, we can use something called runtime parameters. In the next slide, I will have an example for this. You can also have approvals, so there will be pre-approvals, like two people who can approve the actual deployment. The other thing is manual validation or intervention based on the pipeline type. That basically what will happen is you have to log into Azure DevOps and go to the pipeline and click on continue. You have something called branch control that will say that only from certain branch or branches that you are allowed to make the deployment. So here is the example for the runtime parameter. It's a YAML-based pipeline example. The parameter name image, which is a string type, so it can't be any numbers. And it has 3 values only. If you don't give any value, then it will be the default value of Ubuntu latest. So you can't, mess it up and give any other values because it won't be accepted. And on the bottom of the picture, you can see it's the $sign and the 2 curly brackets, how it's used. This is just a screenshot for manual validation and intervention. Here you can see for the release pipeline that there is a pre-deployment approvals. Again, we usually recommend 2 people, and again, the requester shouldn't be able to approve their own deployment. So once you use pipelines, you usually have to use or want to use secrets. The built-in solution is library. Within the library called variable groups, you can have secrets or files. And again, the secrets have the permission or security tab, and you can also choose and customize or make sure which pipeline or which agent or even which user can read or access the secret itself. And if you don't want to use this, then you have the option to use Key Vault integration. Basically, you will be referencing the secrets from the Key Vault, so you will have auditing and central management and rotation from there. I just wanted to say 2 things because I've seen this a couple of times, that GitOps doesn't equal storing base64 encoded secret in Git. So I had this before that company said like, oh yeah, we are using GitOps, and I said, oh, that's very cool. And once I logged in and checked things, I was like, oh no. The other one is that's usually missed is that once you committed a secret and then you remove it, it will be still in the history. So if you have the option to recreate it, then it's good, but at least you need to revoke and rotate the key. So again, we want to prevent reading secrets by anyone or reading like dev from the development environment a production secret, because sometimes, like if, for example, if it's an Azure cloud managed identity with over permissive privileges, then you can have a privilege escalation. So here is the example for the secret. If you are using a variable and you want to make it as a real secret and encrypt it and masquerade, then you will have to use the little icon. So the first picture is the pipeline permission for the secret, so which pipeline can access this secret. So for example, you don't want from the dev environment to access the production secrets. And the next picture is just the usual security. Once you have the pipeline, you want to run the actual steps, so you will use agents. But to use or create agents, you first need to use or create the agent pool, which is basically just a container. You have two options. One is hosted, the other one is self-hosted. The hosted is created and managed by Azure itself, while the self-hosted is created and managed by yourself. So once you have, for example, a virtual machine, you have to create a personal access token and then install the agent, and the agent, it will communicate with Azure DevOps on TCP port 443. It's important because the hosted one is decommissioned and only very few tools are installed, while your self-hosted one, it will live as long as you are allowed it. So you want to make sure what I mentioned in the earlier in the talk, that you don't want to share the agents, especially if it's a sensitive project, because the agent can access different pipelines and different repositories. So if you have two different projects, there is no connection between them except the agent that's shared, then you will be able to access, for example, the second project source code and steal all the files. You have some permission here as well, like who can create or delete the agent itself. And also it's important, it's enabled by default, the updating the agent, because there were some security issues already found in them. So again, we want to avoid stealing source code through agents or reading environment variables or service connections.
Can I ask a question?
Yes?
Can you drop the agents into security groups?
No.
Can you repeat the question?
Yeah, so the question was if I can drop the agents into security groups. No. As far as I know, it's no. So we want to avoid and make sure that only the certain pipelines and the necessary people are reading the secrets, and nobody exploits our agents. So this is the example when you create the agent pools. There is one security configuration here. It says grant access permission to all pipelines. We don't want that, because then all the agents can be used by all the pipelines, and it could go to privilege escalation and other stuff. Here within the agent pool, within the settings, you will see it's automatically enabled agent update settings, so you shouldn't turn this off. So once you build your software, you will create artifact, or if you want to use third-party libraries or registries, that will call upstream sources. But if you use your own internal version of the software or package, then it will be called feed, and you can mix these things. And here again, you will have the permissions. So I just listed some of the attacks, so confusion attack or poisoning attack or hijacking attack and even typo squatting attacks. You will have two options to prevent these attacks. One is enabled by default. It says additional protections when using public package registries. And the other one is when you create the feed, you can exclude the packages from common public resources. We have something called audit and logging. By default, it's turned off because it requires Azure Active Directory integration, and only the organization owners and project collection admins can look at these. You have two options here once you enable. It's audit log and audit stream. The audit log is where you can scroll through in the web UI and see what happened, like a pipeline were running or somebody deleted a secret and so on. While the audit stream is to forwarding all the logs to an external log system, like Sentinel. So we want this because of compliance and reasons or incidents response. It's very helpful, or just tracking changes. Within the organization settings, you will have to enable the log audit events in the security policies. And this is how it will look like. So you will have an additional auditing menu options. That's the last thing before the demo. You have Marketplace, which is will allow you install extensions, so like dashboard widgets or additional build tasks and so on. Bad news is you can't turn this off. Good news is only the project collection administrator group members can install it. Because these extensions are developed by third-party people or companies, you can easily install malicious or vulnerable extension. And there was a small research about this by Jesse, who found more than 1,400 extensions for the pipeline, and basically half of them had one or more vulnerabilities or vulnerable dependencies. This is just an example that you can install or disable. The only option I found is in the pipeline settings. You can disable Marketplace tasks, so in the pipeline what's installed, you won't be able to use them. And I have a demo video. So what you will see here is I will log in as infrastructure, hopefully you will see. Infrastructure as a code developer, and I can only create Terraform codes and create the infrastructure. Because there are 3 projects. One is called Infra as a code and DevOps, but DevOps here in this case is irrelevant. And the third one is Project 2. So in this Infra as a code, I have 2 repositories, and this repository is about using Terraform, and I will do an argument injection. So there is a step that says cd into the folder name, and you can define the folder name by yourself. So what will I do is I will step into the production or test folder, but I also will, because an Azure credential is used, I will also print out or double base64 encode the actual password, otherwise it won't be seen in the output. And I used certutil because this is a Windows self-hosted machine. So here you will see the decoded password. And I will log in to Azure portal, because we have the username and also the password. So I didn't edit the pipeline, I only did an argument injection this time. And because I'm very security navy, I forgot that it's an actual user and it's Azure portal and MFA is enabled. So I have to go through this and we have to see this. But if it's a managed identity where MFA is not enabled and not used, then you are bypassing it and you can access it. So in Azure portal, I see this before as well, that developers or users using automation accounts and they are hard coding their own credentials. I had this as well, and I get access to multiple repositories and projects. So before I continue with that, there is a shared agent between project 2 that I don't have access and this infra as code project. And this time I have the permission to edit the pipeline, and I will modify it. Yes. So basically what I'm doing is, because it's a shared agent, I will list what files are in the current directory, and then I will go one level up and see what else is there. And we will be able to see that there are 3 folders that's relevant. And then I make it short, so I know that there is a secret.txt file, and I will get the content of the secret.txt file, which is in a different directory in a different project. So here we can see I went one folder up, and there are 3 folders, and in folder 1 there is a secret text file and source code. And then at the end, here comes the secret, which is a DEFCON 31 flag. So now I will continue with the account itself. So this will be a developer account. And again, so I'm logging into Azure DevOps, and the conditional access validation is not enabled, so MFA is not required and enforced this time. And you can see there is a project tool that I have no access with infrastructure as a code developer. Here you might be able to see the secret.txt file, and again, maybe it's not visible, but it's the same DEFCON 31 that we've seen previously. So here there is a pipeline step which uses a service connection. That's a service principal for Azure Cloud, and the step is configured that the service principal ID and key can be used and called in the step. So because I'm a developer and I have permission to edit the pipeline, I will double base 64 encode both the ID and the key, and then I will, at the end, I will log in with the credential. And this time I'm using a hosted agent. So it could be that even if I don't have access to read the secret itself, the pipeline will have access to read it, and I have to double base 64 encode, otherwise it won't be seen and displayed in the log. You will just see like stars. At the bottom we will see 2 long strings. Unfortunately, probably you can't see it, but I will share the video itself, and the slides are already uploaded to my GitHub repository. So we can see here this is the service principal ID, and then the key, which is basically the secret for the service principal. And I have an additional credential for the Azure Cloud environment. So I just copy and paste the password, and it's the same ID and tenant. So this is just a summary, what happened. I'm short on time, so I won't go over this picture. I just want to mention that I have like 6 slides about additional resources. These are videos, blog posts, benchmarks, and so on. And even the last one is a Microsoft free learning training, how to use and how things works. And that's it. If you have any questions, feel free to stop me, or you can connect on X now, or write me an email address, write to my email address, and the slide itself is already uploaded to that GitHub repository. And I will share later the video. That's it.